Hello, welcome to Science and Sleep. This is not only a place for you to relax, to find peace after a long day, but also a journey where knowledge and imagination intertwine. Tonight, we will together embark on a voyage beyond Earth, traveling with the small spacecraft that carry the great aspirations of humankind. And to make this journey complete, I hope you will stay until the end of the video, where surprises are waiting for you. If you find these journeys worthwhile, a like and a subscription from you will be a lighthouse, helping the channel continue to light up long nights with science and sparkling dreams. In the tense landscape of the 20th century, amid arms races and the shadow of nuclear war, another race quietly unfolded. A race not aimed at destruction, but at expanding the frontiers of knowledge. When humanity first saw images of Earth from orbit, small and deep blue against the vast void, a feeling both humble and eager crept into the human heart. From that feeling, greater ambitions began to take root. We did not merely want to stand on the moon and gaze at our home from afar. We wanted to reach further, beyond familiar boundaries, to touch worlds that until then existed only as faint specks in the telescope's lens. After the glory of Apollo 11, the world experienced a rare moment of unity, a moment when all of humanity seemed to hold its breath together as a human foot imprinted on the lunar dust. Yet that wonder, no matter how magnificent, gradually faded. The moon, though beautiful and mysterious, was too close to sustain long-term curiosity. After multiple visits, the natural question arose: where would we go next? And in that context, NASA was forced to face a crucial choice: either accept stopping or reach farther into the vast darkness where the giant planets awaited. It was not an easy decision. The 1970s were not a period of prosperity. The US economy wavered, the national budget was tight, and public trust in space programs was shaky. Yet, the most steadfast minds believed this was a moment not to be missed. For the universe had just offered humanity a rare gift: the miraculous alignment of the outer planets. Only once every 175 years does this window open. Miss it, and humanity would have to wait several more generations. That opportunity was nothing short of a cosmic symphony, with Jupiter, Saturn, Uranus, and Neptune aligned like enormous notes on the celestial score. By using each planet's gravity to hop to the next, a small spacecraft could travel farther than any dream nurtured in a laboratory. This idea was called the Grand Tour, a grand voyage, absurd yet real. Initially, the Grand Tour was envisioned as an ambitious masterpiece: 4 probes visiting 4 planets, even aiming for Pluto. But that romance quickly collided with the harsh reality of cost. The US Congress, exhausted after years of colossal Apollo spending, could not accept a massive budget for a fantastical dream. The dream nearly vanished, like a star obscured by the clouds of politics. Yet science has a magical quality. It always knows how to adapt. From the enormous initial idea, a streamlined version emerged. Not 4, but only 2 spacecraft. Not flashy giants, but modest twins, nearly identical. And thus Voyager appeared, no longer a symbol of geopolitical power, but a testament to human perseverance and creativity. JPL engineers, in an era when pocket computers were still a luxury, created mechanical marvels capable of surviving the harsh environment of interstellar space. With no solar power, they turned to plutonium. With no advanced data transmission technology, they relied on giant antennas and signals weaker than the cosmic background noise. And above all, they imbued every screw, every circuit board with a belief that Voyager was not just a machine, but a part of the human spirit. If the Apollo program was a testament to boldness, conquering in a few short years, Voyager was a symphony of patience. Not a fleeting sprint, but a quiet endurance over decades. Initially, few believed the 2 spacecraft could survive beyond 5 years. The primary mission was only to reach Jupiter and Saturn. Yet that modesty opened the door to miracles. For Voyager did not merely arrive. It traveled farther than anyone had dared imagine. And one detail made Voyager truly special. It carried not only cameras, sensors, and scientific instruments, it carried a story. Carl Sagan and his team transformed Voyager into a glass bottle cast into the cosmic ocean, containing a golden greeting from humanity: music, languages, natural sounds, and even the heartbeat of a person in love. On a journey almost certain to never receive a reply, humanity still chose to send a message. We were here. We lived. We loved. We dreamed. Voyager, with all its simplicity and poetry, transcended the boundaries of a scientific project. It became a symbol of the belief that even in the darkest times, we can look up at the sky and find hope. And when the twin spacecraft lifted off in 1977, carrying the aspiration to soar beyond the stars in the Milky Way, few could have imagined that they would write a great chapter in history, an epic of intelligence, patience, and above all, the undying thirst for exploration. Voyager 1 and Voyager 2, though identical in design, wrote two different stories as they left Earth. Voyager 2, the spacecraft launched first, began its journey on a longer trajectory, allowing it to undertake a grand tour, a rare voyage when the giant planets align, occurring only once every 176 years. This opportunity was too precious to miss. In a single trip, Voyager 2 could fly past Jupiter, Saturn, Uranus, and Neptune, something unprecedented in the history of space exploration. Voyager 1, although launched later, followed a shorter, faster trajectory, becoming the first spacecraft to leave the solar system, paving the way for humanity to enter interstellar space for the first time. The twin siblings did not return, but each Voyager carried a unique legacy, the ability to turn imagination into reality. When flying past Jupiter, the giant planet with a magnetic field thousands of times stronger than Earth's, Voyager captured the massive storms that until then had only been faintly seen through telescopes. The Great Red Spot, a colossal swirling storm existing for at least 350 years, appeared in spectacular detail. Smaller storms, spiral cloud bands, and even the auroras at the planet's poles were witnessed by humanity through electronic eyes for the first time. But perhaps the most astonishing discovery was not on Jupiter itself, but on its moons. Io, one of the four Galilean moons, appeared with a mottled red-orange surface. When Voyager took close-up images, scientists discovered that Io was far from dormant. It was a geologically active volcanic world, with lava spewing hundreds of kilometers into space. This was the first time humanity had observed active volcanoes on a celestial body other than Earth, proof that geological dynamism is not exclusive to our planet, and that was only the beginning. As it approached Saturn, Voyager once again amazed humanity. The massive ring system, long an inspiration for poets and artists, under Voyager's gaze became astonishingly intricate. Thin lines, unexpected gaps in the rings revealed the complexity of gravity, where tiny moons acted as shepherds, guiding dust and ice particles along graceful orbits. The moon Titan also appeared as a mysterious world, shrouded in a thick atmosphere rich in methane. This data seeded future missions such as Cassini-Huygens, which later explored Titan in greater depth. Voyager 2, loyal to the Grand Tour trajectory, continued on to Uranus and Neptune, two planets previously seen only as distant, faint blue dots. Flying past Uranus, Voyager 2 discovered that the planet rotates almost on its side, as if a colossal impact in the past had tilted its axis by 98 degrees. Its ring system also unexpectedly became visible, though much fainter and darker than Saturn's. At Neptune, Voyager 2 witnessed another massive storm, the Great Dark Spot, swirling in the deep blue atmosphere, reminding us that giant planets are vibrant, ever-changing worlds. Each stop of Voyager was not only scientific data, but a doorway to expanding imagination. The photos, the numbers, the curves from magnetic field charts became stories, etched into humanity's memory. And when Voyager completed its final flyby, it did not stop. It continued onward, past Pluto's orbit, to the boundary where the solar wind weakens and is overtaken by interstellar space. In 2012, Voyager 1 officially became the first human-made object to enter interstellar space, a historic milestone that no one in the 1970s could have been certain would happen. Voyager 2 followed in 2018, reminding us that these twin spacecraft still whisper, even if their signals are fainter than the universe's whispers. But Voyager carried more than scientific instruments. They also carried a gift, the golden record. On it were music, greetings in 55 languages, sounds from Earth's nature, from raindrops, insect calls, to the laughter of a child. It is a message for any civilization that might find Voyager in the distant future, millions or billions of years from now. The golden record is proof that, beyond exploring the universe, humanity also seeks connection, wishing to say, "We were here. This is our home." These spacecraft, technologically, have long been outdated. They are weak, slow, with less memory than a single photo on today's phones. Yet it is their endurance, simplicity, and clear purpose that made them legendary. Voyager is proof that humanity, despite all its limitations, can still reach far, surpass the stars in the Milky Way, and leave a mark on the vast universe. Today, when you look up at the night sky, those two tiny spacecraft are still out there, quietly moving through the darkness, sending faint signals back to Earth. They are not merely scientific instruments, but symbols of curiosity, faith, and an unending desire for exploration. And whenever we think of Voyager, we are reminded that sometimes the boldest steps begin with the simple belief that something out there is worth discovering. As Voyager approached Jupiter, the giant world suddenly transformed into a lively cosmic stage where layers of gas moved continuously like endless dances. It was no longer a planet faintly visible through a telescope, but a living celestial body, breathing and changing every second. The massive swirling cloud bands looked like enormous rivers of gas, surging with energy unknown to Earth. The Great Red Spot, a storm observed for over 3 centuries, now appeared in remarkable detail like a blazing scar in the atmosphere, large enough to engulf the entire Earth. Yet Voyager also discovered that Jupiter did not have only one storm. Countless other massive vortices, smaller but equally fierce, painted a picture of a planet whose skies never experienced a calm day. Moreover, Jupiter possessed a radiation system and a magnetic field so strong that even scientists were awestruck. Its enormous magnetic field extended millions of miles, sweeping through space like a cosmic machine. Voyager endured intense showers of energetic particles, and through this, humanity learned that Jupiter was not merely a giant planet, but a colossal electromagnetic fortress, protecting and shaping the surrounding space. But perhaps the greatest surprises were not on Jupiter itself, but on the modest moons orbiting it. For the first time in history, human eyes saw the icy world of Europa, the volcanic moon Io, and the enormous Ganymede, larger than Mercury. And it was here that Voyager opened new chapters of exploration. Io, a vividly colored moon, appeared like a surreal painting. Instead of dormant craters like those on the moon, Voyager discovered violently erupting volcanoes, sending material hundreds of kilometers into space. It was the first time humanity realized that geological life still simmered on a distant world. Meanwhile, Europa presented a deeper mystery. Beneath its thick ice layer, surface features suggested the presence of a vast subsurface ocean, an ocean shielded from radiation, potentially containing all the ingredients for life. Voyager did not confirm this, but it planted a seed in human imagination. Perhaps somewhere beneath the icy shell, life awaited discovery. After bidding farewell to Jupiter, both spacecraft turned toward Saturn, the second jewel of the journey. If Jupiter symbolized chaotic power, Saturn embodied elegance and mystery. As Voyager approached, the brilliant rings appeared clearer than ever. No longer a faint band through a telescope, they revealed thousands of interwoven icy rings, forming a cosmic work of art. Grooves, gaps, and ripples in the rings were all recorded in unprecedented detail. Behind this delicate beauty lay a complex story of dynamics, where the gravity of tiny moons created waves and gaps like invisible fingers lightly touching a colossal instrument. Voyager also provided the first close-up views of Titan, Saturn's largest moon. Though thick haze obscured the surface, sensor data suggested Titan had a dense, nitrogen-rich atmosphere, reminiscent of early Earth. A cold world, yet full of potential. This alone made Titan one of the most important targets for future missions. For Voyager 1, the adventure to Saturn also marked a farewell. After completing its mission, it turned north, leaving the plane of the solar system, beginning an endless journey into interstellar space. Voyager 2, more faithful to its trajectory, continued further, heading toward worlds that no human eye had ever seen so closely. In 1986, Voyager 2 became the first spacecraft to approach Uranus, an aquamarine planet unusually tilted, as if someone had knocked it off its axis. The world was frigid, but not still. Voyager recorded massive winds, faint cloud bands, and for the first time, weak sunlight from the distant sun shining on a nearly forgotten planet. It also discovered Miranda, a rugged moon appearing as if pieced together from debris, with cliffs tens of kilometers high, hinting at a tumultuous history. Just 3 years later, in 1989, Voyager 2 approached Neptune, the final stop of the journey. Neptune appeared deep blue, with storms more violent than those on Jupiter, including the Great Dark Spot, a worthy rival to the Great Red Spot. Voyager also discovered Triton, an icy moon erupting nitrogen gas, proving that geological activity still quietly occurs even in the coldest regions of the solar system. This was the first and only time humanity directly witnessed Neptune. Looking back, the journey of the two Voyager spacecraft resembled a grand epic, where each stop revealed a new chapter of the universe. From the violent storms of Jupiter, the delicate rings of Saturn, to the mysteries of Uranus and the dark beauty of Neptune, all contributed to rewriting humanity's understanding of the solar system. The extraordinary part is that all of this was achieved by two small probes carrying 1970s technology with less memory than a modern smartphone. And after completing their planetary encounters, both Voyagers continued their journey, moving away from the sun's light into interstellar space. They now carry not only images and scientific data, but also humanity's message to the universe, the golden record containing music, languages, and greetings from Earth. A reminder that in a tiny corner of the Milky Way, a civilization once looked up at the sky and yearned to surpass it. If Jupiter is a chaotic symphony of storms and power, then Saturn appears as a graceful love song played on the clear strings of the cosmos. For a long time, it has been the shining jewel in the treasure of the solar system, a planet draped in such magnificent attire that even Galileo, with his crude telescope, was bewildered when he first saw it. He called them Saturn's ears, which humanity later realized were the rings, the feature that transformed the planet into a lasting symbol of wonder. Yet Voyager, approaching in the early 1980s, revealed that those ears held far more secrets than anyone had ever imagined. The images Voyager sent back were not merely beautiful. They were a blend of art and science, a vivid painting composed of billions of tiny ice and rock particles spinning in an endless dance. Saturn's rings were not a single bright band as seen from Earth, but thousands of delicate circles, so fine they seemed embroidered with light. There were dim gaps, undulating waves, and even thin, bright lines like a cosmic artist's pencil strokes. All suggested a complex dance so intricate that even scientists marveled, declaring it not just astronomy, but poetry incarnate in orbit. One of Voyager's greatest surprises was the discovery that the Cassini division, the famous boundary between the A and B rings, was not completely empty. Instead of a quiet void, it contained numerous slender ringlets, like forgotten threads. Similarly, the Encke Gap and other narrow divisions appeared as rests in a musical score, creating a rhythm for the icy waltz. Here, Voyager observed shepherd moons for the first time, tiny satellites moving along the ring edges, preventing them from dispersing. They were like silent guardians, patiently shaping boundaries to preserve the delicate balance of the ring system. And while humans marveled at this magnificent dress, Voyager revealed that Saturn's beauty was more than skin deep. Inside this gas giant lay a mysterious world of dynamics. Wind speeds in the upper atmosphere could exceed 1,900 kilometers per hour, far stronger than any storm on Earth. Pale yellow, gray-blue, and creamy white cloud bands twisted into spirals, creating a scene both graceful and violent. Most striking of all was Saturn's North Pole, where Voyager first revealed a gigantic hexagonal structure, an endless storm with a perfectly geometric shape large enough to contain 4 Earths. No one expected nature could produce a vortex so strange yet symmetrical. Voyager also expanded our view of Saturn's rich retinue of moons. Before the spacecraft's arrival, little was known about the planet's companions, but Voyager's cameras transformed them into distinct worlds, each moon carrying its own story. Titan, the largest moon, quickly became the star. Voyager's hazy images revealed a dense atmosphere concealing the surface below. For the first time, humans saw a moon with an atmosphere. And not only that, the atmosphere contained organic compounds, the building blocks of life. Titan immediately became a prime candidate for studying the origins of life in the solar system, a mystery that remains only partially solved today. Not only Titan, but smaller moons like Mimas, Enceladus, and Tethys also made strong impressions. Mimas was famous for a massive impact crater resembling a dead star from a science fiction film. Enceladus, initially only briefly observed by Voyager, hinted that its icy surface was far from static. Young, bright cracks suggested possible subsurface geological activity, a clue later confirmed decades afterward when Cassini discovered plumes erupting from its hidden ocean. In retrospect, Voyager had sown the first seeds for these monumental discoveries. Yet perhaps the most beautiful legacy Voyager left from its encounter with Saturn was not just data or images. It was the feeling that we were seeing the universe through different eyes, the eyes of a small machine, hundreds of millions of miles from home, yet sending us compelling evidence of nature's diversity and creativity. Saturn, through Voyager's lens, was no longer just a pale yellow dot in the night sky. It was a living world with storms, delicate rings, and wondrous moons, all expressing their own voices in a cosmic symphony. And as Voyager departed Saturn, carrying a final gaze of the glittering rings, humanity knew the next chapter awaited. Out there, the icy giants, Uranus and Neptune, still awaited discovery. If Jupiter is the epic of power and Saturn the love song of grace, then the journey to those distant planets promised a new melody, equally surprising and magnificent. If Jupiter and Saturn were already dazzling stages for the Voyager spacecraft to perform, then Uranus and Neptune resembled two mysterious roles, little known, yet capable of silencing the entire auditorium once they appeared. This was the first, and to this day the only, time humanity had the chance to see these two ice giants up close through the lens of an artificial emissary. In January 1986, Voyager 2 flew past Uranus at a distance of about 81,500 kilometers, opening an entirely new chapter in astronomy. At first glance, the seventh planet from the Sun seemed deceptively calm, a pale aquamarine sphere, its surface uniform, lacking the raging storms of Jupiter or the brilliant rings of Saturn. But appearances can be deceiving. Voyager's instruments revealed a peculiar world, with an axial tilt of nearly 98 degrees, causing the planet to spin almost sideways as it orbited the Sun. The result, seasons lasting decades, with one pole bathed continuously in light while the other plunged into darkness. It was a harsh, slow, and alien rhythm, yet it showcased just how creative nature can be. Not only the axial tilt, but Uranus's magnetic field also refused to obey familiar rules. While Earth's magnetic field aligns nearly with its rotational axis, Uranus's twisted in a baffling way. The magnetic field tilted 60 degrees, even offset from the planet's center. This created a warped magnetosphere, swaying with each rotation like a cosmic machine dancing to its own rhythm. Scientists admitted they had almost no model that fully explained this misalignment. And in that surprise, Voyager forced us to rewrite assumptions once thought solid. The moons could not be ignored. Before Voyager, only 5 satellites of Uranus were known. Yet during its brief visit, the spacecraft discovered 10 more. Miranda, a small yet extraordinary world, became a highlight. Its surface resembled a sculpture broken and randomly pieced back together, full of cracks, cliffs, and chasms, twice the depth of the Grand Canyon. Miranda demonstrated that even a small moon could harbor a violent geological history rivaling any planet. It reminded us that in the universe, no place is ordinary if we are patient enough to observe. Just 3 years later, in August 1989, Voyager 2 performed another feat by reaching Neptune, the most distant, coldest, and most mysterious planet in the solar family. No spacecraft had approached it before, and to this day, Voyager 2 remains its sole visitor. If Uranus carried a gentle aquamarine hue, Neptune wore a deep blue mantle like a bottomless ocean. There, Voyager 2 discovered one of the largest storms ever recorded, the Great Dark Spot, a storm comparable in size to Earth, swirling with winds reaching up to 2,000 kilometers per hour. In this icy darkness, the planet contained energy and ferocity beyond imagination. Voyager 2 also explored Triton, Neptune's largest moon, and perhaps one of the strangest worlds in the solar system. Triton orbits in a retrograde direction, suggesting it may have once been an independent celestial body captured by Neptune's gravity. Its surface is covered in nitrogen ice, with enormous plumes erupting columns of icy dust kilometers high. For the first time, humanity witnessed ice volcanism, where internal energy does not spew fire or lava, but cold ice and gas. This discovery opened a new perspective. Icy moons are not dead, but may harbor geological activity and even environments capable of supporting microbial life. Observations at Neptune also led to an intriguing conclusion. Even at the far reaches of the solar system, where sunlight is a mere faint glimmer, there remains intense motion, creativity, and dynamic processes. No planet is silent. The universe, at any distance, is always alive. And when Voyager 2 departed Neptune, it had completed a journey across all four giant planets. It was a scenario that could not be rewritten. A spacecraft launched in the late 1970s using technology now obsolete, yet becoming the only eyes to take us to remote regions of the sky, never before touched. From there, Voyager 2 embarked on a new journey, not as an explorer of planets, but as a silent emissary into interstellar space, carrying hope, knowledge, and a map imprinted with humanity's mark. The blurry images and flickering data sent back to Earth were not merely information. They were stories, proof that humans, through curiosity and aspiration, can extend their vision to the icy edges of the solar system. In retrospect, Voyager did more than change scientific understanding. It transformed how we perceive ourselves, a tiny species living on a single blue planet, yet capable of gazing across billions of kilometers to frozen worlds. Voyager 2 had completed its planetary mission, leaving behind enormous, swirling storms, mysterious moons, and the dim, shadowy rings at the edge of the solar system. Yet instead of ending, that journey opened a new chapter, a chapter no longer tied to exploring familiar planets, but directed toward a realm no one had ever set foot in: interstellar space. While silently drifting through the infinite, the two Voyager spacecraft carried a peculiar message: a recording, a time capsule, a love letter sent to the cosmos. This was the Voyager Golden Record. Imagine this: a gold-plated copper object just 30 centimeters in diameter, small enough to fit in your hand, yet carrying the hopes of an entire planet, of an entire civilization. It was not only a scientific mission, but also a symbolic act, a way for humanity to whisper, "We were here. This is our story. This is life on Earth." The team designing the record, led by astronomer Carl Sagan, faced an enormous challenge: how to compress all of life, culture, and the human spirit into just over an hour of recordings and a few hundred images. They had only months to complete the task, yet the pressure did not stifle creativity. On the contrary, it made every choice, every sound clip, every image be weighed with reverence, as if it were the last chance to tell the story of ourselves. The Golden Record begins with a series of greetings. 55 languages, ancient and modern, echo like a chorus across time. Some greetings are formal, like a diplomatic ceremony addressed to a distant civilization. Others are simple and warm, such as the clear voice of a child: "Hello from the children of planet Earth." No flourish, only sincerity. And it is precisely that sincerity that makes it eternal. Next comes the symphony of the blue planet. Sounds so familiar we often overlook them: the rumble of thunder, the crash of ocean waves, the whisper of the wind, birds singing in the morning, heartbeat, laughter, even the awkward sound of a kiss. These are not merely scientific data, they are everyday moments where humans are seen in their simplest, most fragile, yet most beautiful form. A particularly haunting moment is the song of the humpback whale. The sound resonates, stretches, alien yet familiar, as if from a parallel civilization, yet on the same planet. If any extraterrestrial life were to hear it, they might realize that Earth is not just inhabited by humans, but also by wondrous neighbors who sing through the oceans. Then the record moves on to music. This section is often jokingly called humanity's first interstellar playlist. Over 90 minutes, scientists wove a colorful tapestry, from Bach's brilliant concertos to the hypnotic gamelan of Indonesia, from Navajo chants echoing from the desert to the shakuhachi flute of Japan, sounding like wind through bamboo forests, from joyful Peruvian wedding songs to the soulful blues trumpet of Louis Armstrong, all together forming a flow that crosses continents, languages, and borders. Notably, Blind Willie Johnson's "Dark Was the Night, Cold Was the Ground" was chosen as a hymn for human existence. Wordless, only moans and sighs sliding over the guitar strings, it speaks more than any speech, of pain, longing, fragility, and hope. Carl Sagan once remarked, "If a distant civilization hears this, they will know we too have spent long, lonely nights. And perhaps that is what makes us truly human." But the Golden Record did not contain only sound. It also carried images. 116 pictures of planet Earth. Not only landscapes and architectural works, but also scenes of everyday human life. A mother nursing her child, someone eating, groups dancing together. Alongside these were scientific charts, maps, DNA sequences, and mathematical structures, a universal language enabling anyone, if patient enough, to decode them. The wonder here is not in whether the images or music will ever be discovered. The probability that an extraterrestrial civilization encounters Voyager is nearly zero. The wonder lies in the gesture. Humans knew the chance of response was almost non existent, yet chose to send the message. Sometimes meaning lies not in the reply, but in the act of telling one's story. Looking at Voyager and the Golden Record, we see not just a scientific achievement, but a testament to imagination and humanity. It affirms that in a cold, silent universe, humans chose to speak, and that speech is not made with weapons, nor with ambition for dominion, but through music, laughter, and warm greetings. Today, as Voyager continues drifting farther, carrying the golden record past the stars of the Milky Way, it represents not only the technology of the 1970s, but also a dream. The dream that, however small and fragile, humanity can leave a mark in eternity. And perhaps one day someone will hear it and they will know that in a tiny corner of the universe, there was a blue planet that knew how to love, to dream, and to entrust its heart to a small, shining disk. When we speak of space exploration missions, people often think of technology, enormous antennas, magnetometers, or cold cameras capturing distant images. But Voyager was never just about dry numbers. It is the story of how humanity first reached outward, not only to seek knowledge, but also to express itself. If in the previous section you saw Voyager turn faint dots in the sky into vibrant worlds, now let us view Voyager through a different lens, as a bridge between science, art, and philosophy. What makes Voyager special is not just the photographs or the data. The very act of sending a golden record into space transformed it into a statement that humans, with all their limitations and fragility, still dare to leave a trace in eternity. The golden record is not a scientific instrument. It is a love letter sent to beings who may never exist within our gaze. It contains greetings in 55 languages, the laughter of children, the songs of whales across the oceans, music from Bach to Chuck Berry. It even includes the brainwaves of Anne Druyan, a private, fragile moment, yet simultaneously cosmic in nature. Somewhere out there, in the cold void, these data continue to circulate like an affirmation. We once loved, reflected, and dreamed. But Voyager is not merely a romantic symbol. Scientifically, it completely transformed our understanding of the solar system. Before, the outer planets remained mysteries. Thanks to Voyager, Jupiter is no longer just a hazy gas sphere, but a grand weather machine with enormous swirling storms and a dynamic atmosphere. Saturn is not merely the planet with beautiful rings, but a complex system with hundreds of subsidiary rings, shepherd moons, and electrified cloud bands. Voyager opened a new chapter with the discovery of the strange magnetic fields of Uranus and Neptune, forcing scientists to rewrite theories of planetary magnetism. Each planet, each moon, thanks to Voyager, transformed from faint dots into real worlds with histories, geology, and individual stories. Perhaps Voyager's greatest legacy lies in how it reminds us of our place. When Voyager 1 traveled so far from Earth that its camera could capture a final image, we received the pale blue dot, a tiny, faint blue speck suspended in vast darkness. For Carl Sagan, it was more than a photograph. It was a reminder that all of human history, all wars, all love, all suffering are contained in a tiny dot floating in the void. From Voyager's perspective, Earth is not remarkable for its size or brightness. What makes it remarkable is that it is the only home we have. Voyager thus offers a dual lesson. On one hand, it demonstrates the extraordinary capabilities of human intellect, that from a tiny planet, we could create machines resilient enough to traverse the solar system. On the other hand, it teaches humility, that in the vast cosmos, we are merely a fledgling species sending a clumsy yet sincere greeting. Today, more than 4 decades later, Voyager 1 and Voyager 2 have left the heliosphere and entered interstellar space. They have crossed the invisible boundary where the solar wind ends and the particles from other stars begin to dominate. No human has ever ventured so far, yet these tiny spacecraft continue to send weak signals back. Every bit of data is a miracle, a fragile heartbeat extending humanity's presence into the endless darkness. But imagine, one day, when their nuclear power sources run out, when the antennas fall silent, Voyager will be silent forever. Yet silence does not mean disappearance. They will still travel, quietly passing stars in the Milky Way, carrying the golden record like an immortal time capsule. Perhaps millions of years from now, they will drift endlessly in the void. But the very act of sending them is enough to define our generation. Voyager. Voyager is proof that science is not merely a tool for measurement, but also a way to tell stories. It is the story of a small, finite species daring to question the infinite. And by sending a golden record containing music, laughter, and thought, we have told the universe humanity does not merely exist, we also know how to dream. When we look at the pale blue dot photograph, the first thing that strikes us is the stark contrast between the tiny and the vast. Earth, the only planet we know to harbor life, appears as an almost imperceptible speck in the dark ocean of space. Yet, within that minuscule dot, the entire story of humanity is contained. From empires that rose and fell to the dreams, ambitions, and suffering of billions of people, all share the same coordinate: a solitary pixel. This photograph is not merely a scientific achievement, it is a mirror for humanity to reflect upon itself. Voyager, originally designed only to survey a few outer planets, unexpectedly became a silent philosopher of humankind. It has no thought, no emotion, yet through its mechanical eyes, we have the opportunity to contemplate our place in the universe. In that moment, science transcended the bounds of data and numbers, becoming a source of inspiration for humility and responsibility. In Voyager's view, Earth is no longer defined by national maps or disputed borders. It is the fragile home we have. What is remarkable is that the photograph does not boast. There are no vivid colors or grand spectacles, as when Voyager captured the swirling storms of Jupiter or Saturn's majestic rings. It is simply a faint speck of light among countless others. Yet perhaps it is this simplicity that makes it so profound. Like a minimalist abstract painting, it compels us to seek meaning from within. It tells us that in the cold silence of space, what truly matters is not power or might, but the delicate bonds between humans and their shared planet. Voyager's mission, therefore, is not only an engineering success, it is also a testament to humanity's desire to transcend mediocrity. With computing power weaker than even a modern smartphone, these two spacecraft traversed distances no one dared imagine. And along the way, they left us a spiritual legacy, a reminder that knowledge is not just to expand the scientific map, but also to illuminate how we live on our own planet. From another perspective, the pale blue dot image is also a testament to the power of imagination. It did not have to be taken. In fact, many engineers objected, fearing damage. But thanks to the persistence of people like Carl Sagan, we have this photograph. It is like an artistic gesture within a scientific project, not merely to record data, but to evoke emotion. It shows that when science and art walk together, humanity can create enduring symbols that transcend both time and technology. It is hard not to draw parallels to everyday life when looking at this image. We often struggle with petty conflicts, endless disputes over rights or fame, but from 4 billion miles away, all such quarrels are compressed into a speck the size of a pinhead. This does not erase their personal significance, but it places them in a larger context, the context of the universe. And in that context, the question is no longer who is right or wrong, but how we can coexist and preserve this fragile home as long as possible. Voyager also reminds us that fragility does not mean weakness. Earth is small, yet it sustains diverse and complex life found nowhere else. It is like an oasis in the desert of space, and that preciousness becomes the responsibility of every generation to protect, nurture, and pass it on. In this way, Voyager's photograph transforms every person into a guardian. For if we do not protect Earth, there will be no place to continue this story. Even more remarkable, that spiritual legacy continues alongside Voyager itself. That tiny spacecraft, though far beyond the solar system, still sends faint signals back to Earth, like whispers from an old friend. Those signals carry not only data, but also proof that even across vast distances, connection can endure. They're a metaphor for humanity, that we can sense and listen to one another, even across seemingly infinite space. We can imagine Voyager as a bottle drifting across the cosmic ocean, carrying a message not only for humanity's future, but also for any intelligence that might happen upon it. Inside is the golden record containing music, greetings, and even the cries of newborns. It is a way of saying, we were here, we dreamed, we sought to know more. And even if no one ever hears that message, the very act of sending it is a testament to human faith and courage. Finally, if one lesson can be drawn from the photograph and from the entire Voyager mission, it is the ability to shift perspective. We may think the world revolves around us, that this planet is merely the backdrop for our private stories. But seeing Earth from afar, we realize that all personal narratives are woven into a larger story, the story of life on a fragile planet amidst a cold universe. And that realization, perhaps, is the greatest gift Voyager has left us. Perhaps what makes Voyager a timeless symbol lies not only in its crossing of the sun's boundaries, but also in the long journey ahead of and behind it. Before drifting into the eternal darkness of interstellar space, these spacecraft left a brilliant legacy in the solar system, a collection of discoveries that completely changed the way we view the giant planets and their mysterious moons. When Voyager 1 and 2 were launched in 1977, the initial mission seemed simple: fly past Jupiter and Saturn, send back images and data, and then conclude. No one anticipated that just a few years later, humanity would witness unprecedented phenomena. At Jupiter, Voyager 1 captured the massive storms of the Great Red Spot, where cyclones 3 times the size of Earth have swirled for centuries. The sharp images revealed multi-layered swirling clouds, colors, and structures so rich that all previous models instantly became obsolete. Voyager 2, only a few months later, added to the treasury of knowledge with the first images of Jupiter's moons. Io, a world of active volcanism with plumes hundreds of kilometers high. Europa, ice covered on the surface but hiding a liquid ocean potentially twice as deep as Earth's. Ganymede, the largest moon in the solar system, possessing its own magnetic field. Each discovery was a surprise, as if the universe was gradually revealing its secrets only when we dared to approach. The encounter with Saturn opened another chapter. Its radiant rings, long thought to be a simple icy band, turned out to be a complex system of billions of ice and rock fragments, intertwined and colliding, creating patterns more intricate than any work of art. Titan, Saturn's largest moon, appeared with a dense atmosphere, a mystery not fully understood at the time, but sowing the seeds for future missions such as Cassini-Huygens. Voyager 2 continued further than planned. After Saturn, it reached Uranus, giving humanity its first close-up view of this pale, blue-green planet. Faint, tilted rings, along with Miranda, a small moon marked by cracks and gigantic cliffs, showed that even in the most distant regions, diversity and complexity persist. Voyager 2 then proceeded to Neptune, where a massive dark storm and the frigid moon Triton awaited. Triton, with nitrogen geysers shooting kilometers into the sky, became proof that even the coldest worlds can be dynamic. All these images and data not only enriched textbooks but completely transformed human imagination. From perceiving distant planets as faint dots, we now see them as vibrant worlds, each with its own story. Yet, perhaps what touches the hearts of many is not only the scientific discoveries, but the human significance embedded in every step. On both spacecraft, NASA attached a golden record, a message to any civilization that might find it. It contained greetings in 55 languages, sounds of nature, classical and folk music, and images depicting life on Earth. The golden record was not only a scientific message, but a human whisper. We once existed, we once looked up at the sky, and we dreamed. Today, with Voyager 1 more than 15 billion miles away, its signal is so weak that it takes tens of hours to reach Earth, yet it continues to transmit data. These dry numbers, plasma densities, cosmic ray intensities, become evidence of humanity's unimaginable patience. Even as its nuclear batteries weaken and instruments are turned off to conserve energy, Voyager still performs its work. Perhaps in a few years, it will fall silent forever. But when that day comes, it will not disappear from history. For Voyager has become more than a machine. It embodies the human desire to explore, the ability to surpass seemingly impossible limits. It reminds us that even as small beings, we can send a part of ourselves beyond the stars of the Milky Way to venture where sunlight no longer reaches. In the darkness of interstellar space, Voyager will continue to fly. Not fast, not noisy, but persistent and faithful, like a silent explorer. And perhaps tens of thousands of years from now, when everything on Earth has changed, that spacecraft will still drift quietly, carrying our message to the universe that humanity once yearned, once wondered, and once stepped out to explore the infinite. When thinking of Voyager, people often remember the spectacular images of Jupiter, Saturn, or Neptune. But what makes it a timeless achievement does not lie in those pictures, but in its relentless patience. Nearly half a century of uninterrupted communication with the cold void of interstellar space. Each faint signal we still receive today is not merely raw data, but the echo of a promise from 1977, a promise that humanity will continue to reach outward regardless of distance or time. As energy gradually depletes, every decision to power down a system is like folding a page of a journal. Behind each choice lies not only technical calculation but also emotion. Engineers have worked for years with these instruments, treating them as silent companions. Shutting down a plasma sensor or a heater is not merely a console operation, but a farewell to an old friend who has traveled billions of kilometers with us. In the silence of space, these moments have transformed Voyager from a machine into a living story of patience, creativity, and love for science. Even more miraculous is that despite its aging machinery, Voyager continues to teach us things that no telescope on Earth could replace. Measurements of magnetic fields, plasma densities, and charged particle streams have revealed an entirely new picture of the interstellar environment. It is not a dead void, but an invisible ocean of energy, where solar shock waves still reach, where cosmic rays collide and paint a dynamic and unexpected scene. Thanks to Voyager, humanity could, for the first time, place empirical data into distant space that previously existed only in theory. Throughout this journey, we also see a strange truth. Classic technology becomes a strength. Uh, Voyager's computers, with processing power only a fraction of a smartphone in your pocket, turned out to be far more durable than many modern complex systems. Their simplicity made them easier to repair remotely, even if a software patch took months to test. A memory error, a corrupted signal, every issue was solved by human meticulousness and creativity, like artisans repairing intricate clocks in the void. But Voyager is not just a scientific project. It is also a cultural symbol. The two golden records, with music, greetings in dozens of languages, and familiar sounds of Earth, have made them silent ambassadors. In the eternal darkness, where they may never be found, these discs quietly send a message. We were here. We dreamed, we loved, we lived, and we looked up at the sky. It is a testament to humanity's desire to transcend boundaries, a message both humble and proud. And then, when thinking about the future, perhaps we must accept that Voyager will fall silent. But that silence does not mean failure. On the contrary, it is a worthy farewell. A machine designed to operate for a few years has extended its life to nearly half a century. It has survived Jupiter's fierce storms, Saturn's icy rings, and even crossed the invisible boundary of the heliosphere into the vast universe. That persistence is a triumph far beyond the imagination of its creators. Viewed from another perspective, Voyager is like a reflection of ourselves. We also live in a world with limited energy, learning to choose what to keep and what to let go. Just as NASA engineers must consider every watt of power, humans must consider how we use resources on Earth. In a way, Voyager not only teaches us about the universe, but also reminds us of our own fragility. One day, the signal will cease. We will no longer see the blinking streams of data on our screens, but that does not mean Voyager loses its value. On the contrary, it will become an inspiring story for future generations, people who may build faster, stronger, farther-reaching spacecraft. And then, Voyager will be like the first brick in a bridge reaching toward the stars. In interstellar darkness, those two small lanterns continue to drift, no longer warmed, no longer closely monitored, yet still patiently flying. Perhaps after tens of thousands of years, no civilization will ever encounter them. But that does not matter. Voyager's true value has never been in its destination, but in the journey itself. Like every great exploration in human history, we do not travel just to arrive, but to understand ourselves better, to broaden our horizons, and to prove that in the vast, cold expanse, humanity can still send forth a small flame called hope. Voyager will fall silent, but the memory of it will not. As long as we look up at the night sky and whisper questions about our place in the universe, Voyager lives. It lives in imagination, in science, and in the desire to reach beyond the stars of the Milky Way. When speaking of Voyager, people often immediately think of its long voyages, the famous pale blue dot photograph that Carl Sagan persuaded NASA to take, or the golden record quietly carrying the voice of humanity. But to fully understand the significance of Voyager, we need to pause and reflect. What truly makes these two metal spacecraft, originally designed for just a few short years, become some of the most enduring symbols of human science and imagination? First, Voyager is a vivid testament to patience. In an era where information travels instantly, waiting nearly 45 hours just to send and receive a signal seems almost unreal. Yet it is precisely this distance, this delay, that highlights the endurance of those who monitor the faint heartbeat of the spacecraft day and night. A single wrong command could result in permanent loss of contact. And yet, for decades, the quiet engineers at the Jet Propulsion Laboratory, JPL, persevered like keepers of a flame, ensuring the Voyager light never went out. Voyager also reminds us that sometimes value does not lie in the volume of data returned, but in the spiritual meaning it conveys. Every signal sent back by Voyager, however scant, is like a whisper. I am still here. I am still telling you the story of the universe. In the infinite silence of space, that echo is both fragile and enduring, like the heartbeat of humanity in the cold void. But the story becomes more complete when we look at what Voyager carries, the legendary golden record. Not a purely scientific tool, it is a message. It speaks not only to extraterrestrials, but also to ourselves. This is what humanity wants to remember. This is the symphony of life on Earth. The sound of wind, the crash of waves, the laughter of children, heartbeats, and colorful music, all compressed into a tiny, fragile, yet courageous memory capsule. Another civilization may never decode the full content. To them, our music might only be chaotic vibrations. But the truth is, even if no one out there hears it, the very act of sending a message says a great deal. It expresses a desire to transcend the limitations of a single human lifetime. It shows that humanity, with all its contradictions and imperfections, still longs to leave a mark, to assert, we were here. Thus, the Golden Record is not merely a greeting for some anonymous visitor in the future. It is a mirror for humanity to reflect upon itself. Listening to Johnny B. Good, we see not only Chuck Berry, but also the youthful vitality of a flourishing culture. Hearing the sound of the sea or a heartbeat, we recognize not only Earth, but also the primal connection among all of us. Imagine a little further. Thousands of years from now, if someone in the galaxy were to actually find Voyager, what they would see would probably not be a perfect scientific portrait of us, but a patchwork, full of gaps, awkward but sincere. It is precisely this awkwardness that makes Voyager special. It is not the blueprint of a supreme civilization. It is merely a glass bottle containing fragments of memory, cast into the infinite ocean with the faint hope that someone might find it. And sometimes, it is these fragile hopes that make humanity beautiful. Looking at Voyager, we also see another lesson. The most important legacy of science is not just technology, but inspiration. Future generations may no longer maintain contact with Voyager, but the idea of Voyager will continue to drive them. Like the stars, Voyager will remain present in our minds, not because it shines, but because it reminds us to dream. In the darkness of interstellar space, Voyager will drift without purpose. But in our imagination, it has become a symbol of perseverance, of the belief that even a small voice can carry far. And perhaps that is the greatest lesson these two small spacecraft leave behind, that not every mission needs a destination. Sometimes the journey alone is enough to create lasting value. When speaking of Voyager, people often think immediately of its long voyages, of the famous pale blue dot photograph that Carl Sagan persuaded NASA to take, or of the golden record quietly carrying the voice of humanity. But to fully grasp the meaning of Voyager, we need to pause and reflect. What truly makes these two metal spacecraft, originally designed for just a few short years, become one of the most enduring symbols of human science and imagination? In a sense, Voyager is more than just a machine. It is like a mirror reflecting how we understand ourselves. When humanity sent those spacecraft, we did not merely send sensors, cameras, and measuring instruments. We sent a philosophy that exploration does not serve only immediate benefit, but is also an affirmation of our desire to surpass our own limits. People might ask, why launch these tiny spacecraft beyond the solar system instead of focusing on the unresolved problems here on Earth? The answer lies in the very nature of humanity. We constantly look toward the horizon, constantly ask questions, constantly seek something greater than everyday life. Voyager is a testament to that need, the need to know that out there we are not alone in our curiosity. Throughout the years drifting through cold space, the two spacecraft transformed faint points of light in the sky into tangible worlds, with mountains, seas, storms, and astronomical phenomena beyond prior imagination. Without Voyager, Jupiter might still be just a bright speck in a telescope rather than a planet seething with storms larger than Earth. Saturn might still be a planet with beautiful rings, but unrecognized as a complex ecosystem where slender bands conceal subtle and violent movements. Uranus and Neptune, the distant icy worlds, might still be territories of vague hypotheses. Voyager turned all of these into collective memory, into data, into stories for future generations. Yet Voyager's legacy goes far beyond pure science. It awakens a sense of wonder that we sometimes forget in the rush of daily life. When the first images from deep space returned, many people wept, not because the data solved a specific problem, but because it stirred pride in their hearts that this tiny human species could reach so far, touching the secrets of the universe. A photograph may only be pixels, but to the human mind, it is proof of resilience, of a vision that accepts no limits. And then, as Voyager carried out its scientific work, it simultaneously became a storyteller. The golden record, containing music, greetings, and sounds of Earth, was not a technical requirement. It was a humanistic choice. When Carl Sagan and his team compiled the music, laughter, children's voices, and heartbeats, they understood that the chance of an extraterrestrial civilization actually finding it was extremely small. Yet they did it, because in that act lay a profound statement that our existence is worth preserving, that we want to be remembered not only for power or technology, but for culture, emotion, and compassion. Voyager also teaches us about patience. In a world always craving instant results, the two spacecraft quietly worked, year after year, sending back fragile streams of data to their home. They had no dramatic moments like landing on a planet, no raucous cheers like a rocket launch. They only had persistence, and it is precisely that persistence that created a miracle. Perhaps this is a greater lesson than any discovery, that progress does not always come from explosions. Sometimes it comes from whispers in the dark. And when we look back, Voyager also reminds us that science and art have never been separate. The spacecraft transmitted more than dry data. They inspired. They opened books, music, films, dreams. They showed us that space exploration is not only the work of laboratories, but a collective story of all humanity. When a child sees the pale blue dot, Earth, tiny as a speck in space, they learn not only about astronomical distances, they learn about fragility, about the responsibility to preserve this planet, about the solidarity required among everyone sharing that faint blue dot. Ultimately, the journey of Voyager is like a message that space exploration is not an escape from Earth, but a way to understand Earth more deeply. The farther we look, the clearer the value of our home becomes. The farther we travel from the solar system, the more we realize that everything familiar, seas, mountains, forests, and people, is unique and priceless. Perhaps it is here that Voyager became a mission not just of NASA, not just of the United States, but of all humanity. Today, as Voyager continues silently drifting through interstellar space, it is like a faint lamp still persevering to shine. The weak signals it sends back to Earth are a slow but steady heartbeat, reminding us that the adventure is not over. And even if one day the spacecraft falls silent forever, that silence will not be an end. It will be another chapter in humanity's long story, the story that we dared to send a piece of our soul into the universe, and that in that endless darkness, hope still resonates, proving that reaching outward always has meaning. When thinking of Voyager, we often recall distance, the cold numbers of billions of kilometers, speeds faster than a bullet, coordinates and signals that only scientists can interpret. But if we strip away the layer of data, Voyager may actually be a very intimate story. It is like a bottle drifting on a vast ocean, carrying a small piece of paper with a few lines written on it. We were here. We once dreamed. That's all. Simple, yet immortal. Imagine, out there, the darkness is so dense that light itself takes tens of thousands of years to travel. No harbor, no signposts, no place to land. Only a small spacecraft quietly carrying the breath of Earth. It needs no one to watch, cares not for glory. Yet its mere existence, its small but persistent presence, is proof that we, a fragile species, once dared to send a piece of our heart into the universe. Voyager shows us a beautiful paradox. The farther it goes, the more it makes us think of home. The images it sends back not only reveal the majesty of Jupiter, Saturn, or the distant icy moons, but also remind us how small and unique our blue planet is. In the universe, Earth is not the center, not a ruler, but just a fragile speck among countless stars. And precisely because of that, it becomes priceless. When we see our home as merely a faint dot in the darkness, we gain a profound understanding of rarity, of responsibility. Perhaps Voyager is not just a scientific mission, but also a spiritual experiment. It poses a silent but resonant question. Do we have the courage to create something that offers no immediate benefit, yet nurtures meaning for generations? In a world that constantly demands efficiency and profit, Voyager is like an offbeat melody. It promises no wealth, no power, only the opening of doors to wonder. And somehow humanity has accepted to step through that door. By sending the golden record, humanity chose to tell its story through the simplest sounds: children's laughter, the crashing of waves, the beating of a heart. Strangely, we did not send weapons, did not send symbols of power, but the most fragile and tender things. This shows that deep within our nature, we are not just a species of technology, but a species of memory, melody, and dreams. And perhaps that is the strongest message of all, that amid eternal silence, we chose to sing. Voyager also makes us reflect on the concept of legacy. One day, the signals will cease, energy will run out, and we will no longer hear the calls from those two distant spacecraft. But their legacy does not lie in numbers or data, but in the inspiration they sow in human minds. How many scientists embarked on a research path because they first saw a Voyager image? How many children looked up at the sky and believed they could go further, knowing a spacecraft was truly doing it? And how many found comfort in knowing that, in the endless darkness, a small fragment of humanity still whispers? On another level, Voyager is a test of faith. We do not know if anyone out there will ever find the golden record. The probability is nearly zero. Yet we sent it, like a greeting without expecting a reply. In a pragmatic world, that act seems pointless. But in a world of hope, it is the most precious thing. For sometimes, merely saying hello is enough. Simply sending it is a testament to the belief that the universe somehow is worthy of our kindness. And perhaps the greatest wonder of Voyager lies in the fact that it does not try to return. It just goes. It keeps going forever. In a culture often obsessed with returning, with destinations, Voyager chooses to drift endlessly. It is like a story written without ever closing, a journey without a required ending. And in that very infinitude, it offers a strange comfort, that even if we are gone, something continues, a whisper of humanity still lingering among the stars. So, when thinking of Voyager, we do not just think of two old metal machines drifting alone in space. We think of a symbol, that we once dared to step beyond the familiar, once dared to believe that the question is as important as the answer. And perhaps at this very moment, as you listen to this story, Voyager is still traveling, still sending back a faint signal like a distant heartbeat, a small yet persistent heartbeat, a heartbeat of ours.